Okay, final answer. Calculator problem. If you have not already, which I'm pretty sure you have, make sure you have your calculator out. We've got a certain population of bacteria in thousands in Mr. Lehigh's shoe, which can be modeled using the function. And we've got that function right there. And then it says, find the average rate of change for t equals 10 to t equals 20, then describe what it means in the context of the problem. So this is where we're going to be practicing what does it mean to be an average rate of change for a word problem. What is the rate of change that we're talking about between the variables? What's happening with germs, bacteria, for Mr. Lehigh over time? Okay, so first I'm going to go ahead and graph this in my calculator. Let me zoom out so you can see what I'm typing in. First I'm going to go to my graph here. I already got something graphed in here, so how I'm going to bring my graph back to normal is I'm going to double click in the white space. You'll notice that you automatically jump to f sub 2 if you have something there. If you scroll up, it goes up to f sub 1. So I can press Control Delete, which will clear everything. Then I press Enter, and everything goes away. So again, you would press double click on the white space, scroll up. Now it brings me to the 99th function that I can graph. Now I'll escape. Then you would clear it out. I also want to reevaluate where my zoom is. Notice how large my zoom is right there. So if I hit menu, which is your go-to button with graphing and with anything with your calculator, go to menu, and then I want to change my window and my zoom. TI-84, guys, there's a spot that specifically says zoom on those top options. And so you can do this as well and go to that zoom. And I want to go to zoom standard. There is a zoom standard for TI-84s as well. I think it's if you go all the way down to the bottom, or I don't know exactly how far, but there is a zoom standard for TI-84s. Now I'm in a place where I'm looking at a nice basic graph. So it's nice to start off with a clean blank slate. I'm going to double click in my white space. TI-84s, go to your y equals 0.055x squared plus 2.8 x plus 220. I went ahead and did x instead of t. Nothing crazy, just did that instead. Then I'm going to go ahead and press enter, or graph if you have a TI-84. I don't see anything. Don't panic. It just means you need to zoom out. We've got a vertical shift here of 220. We're way the hell up there. Menu, zoom, out. Then it says center. Notice that my little guy is right there. Every time you press enter, it zooms out. I don't have to do anything else. I just keep pressing enter. Ta-da! Something else that's cool, if you want to kind of like with your mouse where you click and drag to bring the window where you want, you can also do that with your graph. If you click and hold in the white space, it looks like it's grabbing a sheet, right? I've stopped. I just clicked and held until that symbol came up. And now I can just bring this guy down like this. And now I see it in a way that I like. You can also do that with your function that's represented right here. If you hover over it until you've got an open hand, click and hold until it becomes now a pinch hand. I'm not touching it, right? So now it's pinched and it's holding it for me. I can then scroll where I want to put this graph, or this equation. Maybe I want to put it right here, so it's a little bit easier for me to see. I press enter, it's released. I've now got all of this. Okay, so what are we doing here? We're trying to find the average rate of change. Well, your average rate of change is f of x sub 1 minus f of x sub 2 over x sub 1 minus x sub 2. I have my x sub 1 and my x sub 2. But I do not have my f of x sub 1 or my f of x sub 2. You can use your calculator to find those y values. What we're going to do is we're going to trace on this graph. And what it means to trace is it means to follow what's going on the graph. Almost like you're tracing it with a pencil of okay, what is the y value when I'm talking about an x value of 10? So you would be tracing it like this, but your calculator does it for you. You're going to hit, I'm sure you guessed it, the menu button. It's the button we press for everything. If you don't know where to go, first click menu and then see if maybe you can figure it out. Trace. We're going to be tracing our graph. So you can either scroll down by pressing this until you hit graph, or you can just press the number 5. Boom. Then I want to graph trace. I don't know what any of those other ones do. I only ever use graph trace. So you press 1. TI-84s, there's also an option to trace the graph. So see if you can find it. If not, ask in class, Mr. Serene. I am more than happy to help you figure out how to use your TI-84s. Once you've gotten here, you then want to find out what is the y value when x equals 10. All you have to do is type in, notice my finger down here, 1, 0, 10. Press enter. It has now brought your little bullseye point to that coordinate, and then it's told you down here at the bottom what that coordinate is. Your coordinate is 10, 254, which means that your y value for that is 254. Go ahead and try this on your own. Rewind if you need to have a refresher on how to do these. Rewind to rewatch the instructions if you need, but try this now on your own with x equals 20. All you have to do is type in 2, 0, enter, and your y value is right here, 298. That's it. That's all you got to do. Another thing that your calculator can help you with. Okay. Now that I have these values, I'm going to go ahead and plug them into my, my formula right here. So I've got f of x sub 1, 254, minus f of x sub 2, 298, all over x sub 1 minus x sub 2. Go ahead and tell me what you get. We get a value of 4.45. It's like 44, that is not the same as what I wrote down. Hold on one second while I'm double checking. Yep. So my answer key must be wrong. Sorry, please, thank you for sticking with me. So we get an answer of not that. So let's try it. 254 minus 298 divided by 10. We get a value of 4.4, which is fine. That's great. That's the average rate of change. Notice if we go back to that graph, the average rate of change between 10 and 20, we're talking about like a pretty steep part of the graph, and 4.4 is a pretty steep slope. Now, it does say to describe what it means in the context of the problem. And the number one thing that I would recommend here is remember that your slope is your change in y over your change in x. And take a minute and think about, what does y represent here? Go ahead and tell me, what does y represent? Y represents P of T, it represents population of bacteria. So number of bacteria, or pop of bacteria. Pop of bact. X represents time. So if you get 4.4, you can think of it as 4.4 over 1. So if we've got this relationship of a slope, or an average rate of change, being 4.4, you can say, oh, well, what that means is it's 4.4 bacteria over 1 of the time. The time is in minutes. So try and think about, what does this mean in relation to the context of the problem? It means that for every minute, Mr. Lehigh gains, because it's a positive, 4.4 bacteria. For every minute, Mr. Lehigh gains 4.4 bacteria. It's this rate of change between your two variables. What's the relationship between bacteria and minute? Well, for every minute, 4.4 bacteria. Or you could say we gain 4.4 bacteria for every 1 minute. There's ways that you can state it, but realize that that slope is a relationship between your two variables. What's happening as x changes? What happens to the y? And that's all slope is telling you. Very good job today.